How do you keep an entire family alive when the air itself is trying to kill you at minus 55 degrees Celsius? The Mongolian steppe becomes one of the harshest inhabited environments on Earth. Steel can crack in the cold, and exposed skin freezes within minutes. Wind speeds can rise above 100 kilometers per hour, carrying ice crystals sharp enough to cut exposed flesh. There are no forests to burn for warmth, no permanent stone shelters, no mountains to block the storms sweeping across the open plains. And yet, for centuries, nomadic Mongolian families survived here in portable homes made from wood, wool, leather, and rope. The question is not simply how they survived. The real question is why their system worked so well that even modern cold-weather engineering still struggles to match its efficiency. Because the Mongolian gyr was never just a tent. It was a machine built for survival, and every part of it existed for a reason. Winter on the steppe is not dramatic in the way outsiders imagine. It is not constant blizzards and endless chaos. It is worse. It is silence. Endless white distance. Wind that never completely stops. The cold is so deep it changes the behavior of wood, metal, animals, and human breath itself. The Mongols developed a word for catastrophic winter disasters: dzud. It is a season where deep snow, ice crusts, and brutal cold kill entire herds by the thousands. In some winters, livestock freeze standing upright on the open plains. For nomadic families, survival depended entirely on mobility. Permanent stone villages were impossible. For a culture built around moving herds across massive distances, their homes had to travel with them. But mobility created another problem. How do you build a structure light enough to transport across the steppe, yet strong enough to survive Arctic-level storms? That answer began with shape, and the shape they chose would become one of the most efficient cold-weather designs ever created. Most ancient shelters fail for one simple reason. Flat walls fight the wind. The gyr does not. Its circular structure allows hurricane force winds to flow around the exterior instead of slamming directly into rigid corners. There are no sharp edges for pressure to build against, no tall vertical walls waiting to collapse. The design behaves more like a living system than a rigid building. The walls are constructed from expandable wooden lattice sections, traditionally made from lightweight larch or willow, instead of iron nails. The joints are connected with rawhide straps that remain flexible in extreme cold. This flexibility is critical. A rigid structure cracks under pressure, but the gyr bends instead. During storms, the walls can move slightly with the wind, dispersing force across the entire frame. Modern engineers call this dynamic load distribution, but Mongolian nomads mastered it centuries ago using only wood and leather. At the center stands the most important component of all, the roof ring. Without it, the entire structure fails. The roof ring is more than an opening in the ceiling. It is the structural heart of the gyr. Heavy roof poles extend downward from the circular crown to the lattice walls below. Once assembled, the downward pressure from the roof locks the entire structure together through tension and compression alone. With no internal nails, no bolts, and no permanent anchors, the building stabilizes itself using gravity. This allowed nomadic families to construct or dismantle an entire home in under an hour during dangerous weather shifts. But the roof ring served another purpose. It controlled light, smoke, airflow, and even time itself. Sunlight moving across the interior floor acted as a natural clock throughout the day. Smoke from the stove escaped through the center opening while still trapping enough heat inside to maintain survivable temperatures. Every function inside the gyr served multiple purposes, and nothing was wasted. That efficiency became even more important once temperatures dropped below minus 40, because structure alone could not save them. The true battle was heat in deep winter, and the difference between life and death is often measured in insulation. The Mongols solved this problem using one of the oldest engineered materials in human history, felt. Felt is made by compressing and matting sheep's wool together into dense, insulating layers. But wool contains something even more valuable than warmth. Lanolin, a natural wax coating, makes the material water-resistant while still allowing it to breathe. Snow and moisture remain on the outer surface instead of soaking into the insulation inside the fibers. Countless microscopic air pockets trap body heat. Air is the real insulator, and the yurt trapped enormous amounts of it. During extreme winters, multiple thick felt layers were wrapped around the structure, sometimes reaching nearly several inches in combined thickness. Additional outer canvas protected the felt from snowmelt and freezing rain, and the result was astonishing. Outside, temperatures could remain below -55°C, while the interior rose to survivable levels within less than 30 minutes after lighting the stove. But warmth created another danger. Moisture in Arctic cold can quietly destroy an entire shelter from the inside out. Many people imagine cold as the greatest threat, but on the steppe, often it was condensation. When warm air from cooking, breathing, and heating touches freezing surfaces, moisture forms rapidly inside enclosed shelters. If trapped, this moisture freezes into ice within the walls and insulation, and over time, frozen moisture destroys warmth. The Mongols understood this long before modern building science explained it. The roof flap of the yurt was constantly adjusted throughout the day to regulate airflow. Families controlled ventilation carefully, balancing heat retention against moisture buildup. Too much ventilation, and precious warmth escaped. Too little, and the felt became damp and dangerous. Even the placement of the door mattered. Yurt entrances traditionally face south, away from the brutal northern winds sweeping across Siberia. The lower edges were sealed tightly against ground-level drafts, where the coldest air accumulated. Meanwhile, smoke from the central stove slowly coated the interior roof poles with soot, helping preserve the wood against moisture damage and insects. Nothing inside the jar was accidental, not even the fuel, because on the treeless steppe, firewood barely existed, and survival depended on burning something most civilizations would never consider. There are regions of Mongolia where trees simply do not grow, yet winter heat remained essential. The answer came from the animals themselves. Dried dung from horses, cattle, sheep, and yaks became the primary winter fuel across the steppe. Once dried, dung burns slowly, steadily, and efficiently, and it produces long-lasting heat with relatively little flame, making it ideal for enclosed spaces. For outsiders, this sounds primitive. In reality, it was highly practical energy management. Nomadic families stored fuel carefully throughout warmer seasons, understanding that a single failed storm week could become fatal if the fire died. The stove inside the gyr was never merely for comfort. It was the center of survival. Food simmered constantly above the heat source, and animal fat, bone broth, and salted meat provided the calories necessary for surviving severe cold exposure. Traditional Mongolian winter diets were extremely high in fat, because the human body burns enormous energy trying to maintain internal temperature in deep winter. Calories became fuel, as important as the fire itself, and outside the shelter another battle continued through the darkness, the survival of the animals. A Mongolian family could not survive without its herds. Horses, sheep, goats, cattle, and camels were transportation, food, clothing, trade, fuel, and wealth combined into one living system. The animals were not separate from survival. They were survival. Mongolian horses evolved remarkable cold resistance, surviving brutal winters with thick winter coats and the ability to scrape snow aside to reach frozen grass below. But during severe storms, even these animals required protection. Secondary shelters were sometimes built for weak or newborn livestock. Emergency feeding became constant work during heavy snow periods. Every morning began with checking the animals before checking comfort, because if the herds died, the people eventually followed. And while storms raged outside, life inside the gyr continued in a carefully organized rhythm designed around heat conservation. People slept elevated from the frozen floor, where the coldest air collected. Thick wool rugs and layered animal skins trapped warmth beneath sleeping areas. The fire burned low through the night, never fully extinguished during the deepest winter months. Outside, the wind continued scraping across the plains like an endless ocean. Inside, the gyr remained a small island of controlled warmth, but only because its inhabitants maintained it. They never stopped maintaining it. Survival on the steppe was never achieved once. It had to be rebuilt every day. Snow accumulated against the outer walls constantly, and needed removal before ice trapped moisture inside. The felt layer's frozen buildup around the base had to be cleared to preserve ventilation. Water required labor as well. Liquid water often did not exist for months at a time. Families harvested blocks of river ice, transporting them back to camp for melting. Over the steppe, ice was easier to transport than sloshing containers of water in brutal wind conditions. Winter also became repair season. New felt was produced, clothing was reinforced, and boots were lined with additional wool layers. The traditional deal, a thick, double-layered robe tied tightly around the body, functioned almost like wearable insulation. Everything revolved around retaining heat, because on the Mongolian steppe, comfort was never the goal, efficiency was. That may be the greatest reason the gur survived for so long. Even now, after centuries of technological advancement, the logic behind the structure still works, which raises a strange question. What exactly did ancient nomads understand about survival that modern society sometimes forgets? Modern civilization often tries to conquer nature. The Mongolian gur did something different. It adapted to it. The structure does not resist the wind with brute strength. It flows with it. It does not depend on massive foundations, electrical systems, or industrial materials, just wood and wool. Leather rope, heat airflow, and human discipline combine into a complete environmental system, refined over centuries of trial and survival. That is why the gyr remains one of the most efficient cold-weather dwellings ever created. This was not because it was primitive, but because it understood exactly what the environment demanded. Long before modern insulation science, portable architecture, or thermal engineering existed as formal disciplines, nomadic families on the frozen steppe had mastered them through experience. And perhaps that is the real lesson hidden inside the endless winter plains of Mongolia. The people who survived the harshest environments on Earth were not always the strongest. Often they were simply the ones who learned how to live in balance with forces they could never control. If you enjoyed exploring ancient survival systems and forgotten engineering like this, subscribe to Shadows of Valhalla. For more journeys into the extreme realities of human history, remember this. Because some of humanity's greatest inventions were not built to conquer the world, they were built simply to survive another night.